Welcome everyone. This is the Antrea community meeting. Today is May the 5th, 2020. Of course, for people in the United States, it's still May the 4th. And well, let's get started with this meeting. The agenda for today, it's fairly simple. We will start with a discussion of the OVS hardware offload proposal. I guess Moshe will give us his presentation. And then once that is done, Cody has some feedback about cluster network policy that we discussed in the previous meeting. All right, so is there any other topic that you would like to add to the agenda? Perfect. Silence means that we are ready to get started, and therefore we'll start with discussion of issue 630 and the support for OVS hardware offload. And I will therefore shut up and leave it to Moshe.
Hi guys, can you hear me? You guys can hear me?
Moshe, we cannot hear you.
You can't hear me at all?
Now it seems it's better. Can you try again?
Yeah, can you hear me now?
It's good now.
Yeah, I can hear you.
Okay. Yeah. Hi everyone. My name is Moshe. I'm working for Mellanox. Yeah. So basically, I'm not sure if you are familiar with the Mellanox or with the hardware offload, but basically, we have a solution to accelerate the OVS using SRV technology and the concept of buffer presenter, buffer virtual function. And basically, in the design proposal, we're trying to address it to the record. You want me to go over on the solution, or you view it and you have questions? So you want to do it? My first time. Please continue.
I think a quick overview could be good.
Okay. Yeah. Okay. So basically, we are using several things here in the design proposal. Because we are using the SRV technology, you will need to use the SRV device plugin. The SRV device plugin basically allows us to do allocation of the PCI address. Not doing the PCI allocation, but it's actually reporting to the kubelet, and kubelet should select the available virtual function per of the request per request of the resource in the prospect. The second component that we are using in the solution is Multus. Multus is a CNI which basically addresses the problem of multi-networks, multi-interfaces in the container. But we are not using it for that because we are using it in a different way, just to allow us the communication between the SRV device plugin and the CNI, actually retrieve the VAF PCI address from the device plugin and pass it as a CNI args to the CNI. The way that it does that is actually by connecting to the Kubernetes masters, and according to the network attachment definition, the resource appears in the network definition. He actually retrieved the the pod allocated resource and then pass it as a CNI args in the extra CNI args as a device ID. Okay. Yes, and once the Antrea project, once the CNI has the PCI address in the extra spec, then the logic in the Antrea project just changed. If we have a device, this device ID passed to us, then we are doing it the way we plug the network interface in the container will be that instead of creating VTH pairs like the current code is doing, what we will do is just get the PCI address of the VAF, get this net device of this virtual function, pass it to the container, and from the PCI address we also need to find the VAF representer, and then we take the VAF representer and we plug it to the OVS. And after that, basically the code is mostly the same. So we have the net interface container and the VAF representer and a device. In our case, it will be the VAF representer connected to the PRM. And that's it. That's the whole orchestration part. Any questions on that?
Can you talk a little bit about the, and maybe you haven't gotten to this, the topology manager feature in Kubernetes and how you're using that?
Topology manager?
Yes.
Yeah, so basically because it's SRIOV, so we want that CPUs and then PCI NIC would be on the same node. Currently, from topology manager, there are 3 policies that are supported: single NUMA, best effort, and restricted. The one that fits for this use case is the single NUMA node. We want to make sure that the virtual function and the CPUs will be on the same NUMA node and not something like best effort thing. From the Kubernetes perspective, it's just to enable the topology manager feature and to the policy of the single NUMA. And of course, when you do the request, you need to request also CPUs, right? So on the pod spec.
Thanks.
Sure, no problem. Another point to talk about maybe, because we're using Multus and basically we're using it to pass the CNI, it means that I know currently you have the configuration of the CNI in the CNI conf, right, folder, but in this case, what will happen is the Multus configuration will be in the CNI conf, and basically we will need to use a CRD of the network attachment that's explaining what is the Antrea configuration for the Kubernetes network. And so this is a different way of doing the network configuration than what you did today. Okay. And that's it. Any other questions?
Yes, I have some question about OVS of load. So,
Yes.
so right now, OVS support 2 ways of load, right? So first is to use DPTK RTE flow interface, and the other way is to use TC flower. So I guess in this case, your proposal is using the TC flower interface. Am I right?
Yes. So this all the scope of the current changes is the flower, which means the OVS kernel. Regarding OVS TPDK, we can do it. There is also the concept of VAF representers in OVS TPDK without load overflow, the ways mentioned. currently I put it as out of scope, but I think we can do it like in a second phase if we wanted. I just wanted to focus on one use case, and from the Mellanox perspective, the obvious kernel is the one that is most, I would say, mature. Yeah, but definitely we can add obvious TDK support without the workload later.
Okay. Yes. So yeah, I think it's definitely makes sense to focus on the kernel data path first. Another question is that right now for Antrea, I think basically we are using multiple data path flows, meaning that a packet comes into the obvious data path and it will do encap or decap, and then it will do connection tracking, and then it will match another rule and then send it to the destination port. So which means that the packet will recirculate, hitting flows, like hitting 3 flows and then sending to the destination. So is right now this offload mechanism, so we don't want to do any partial offload because any processing that goes to fallback to software will reduce to either to the same as software flow. So
yeah, so I understand. So TC flow is a full offload. So it means from that perspective, the TC web even what you said about connection tracking when you circulate. If we can offload all the entries of that single packet, right? Then it will be offloaded to the hardware. In case we don't support any of the actions of the specification, then we go into software. So and currently there is work on connection tracking. In OBS, it's already in 2.13, and from the kernel perspective, most of the connection tracking effort for the OVS kernel, I think most of the pieces are in the upstream kernel. But definitely the plan is to do, it's either you do full offload or you don't have anything. Right?
yes,
There's no partial offload here.
So are you saying that can you do connection tracking at hardware right now, or right now the connection tracking has to fall back to the kernel implementation?
So currently I just did the orchestration. I didn't quite started to actually test the connection tracking and the concept of this in this with Antrea. We do connection tracking testing with other controllers. From what we just analyze the flows, and from the flows it seems like we can do also for this one. So,
I see. Saying, and I know like some hardware like Broadcom, they have some limitation about recirculation. So meaning that okay, they can test connection tracking in hardware, but if you want to combine, first doing connection tracking, then doing tunnel encap, then it couldn't do that. Just saying that okay, you cannot recirculate packet back to the beginning of the hardware pipeline. So do you guys aware of this problem, or it's okay in your hardware to do this recirculation and combination?
No, it's okay from our perspective. That's what we're working on, all of the upstream connection tracking. So it's not going to be just connection tracking. We understand the connection tracking and other obvious actions that come along with it.
I see. Okay, thank you. That's all my question.
But another point regarding the things here is currently once I read the documentation, it seems like currently you only support full OVS open flow configuration only in the scenario of protocol traffic, and it seems like the project is still using Cube proxy. For services, right, and external network traffic. Am I right?
Yeah, that's correct. But somebody is working on implementing kubeproxy functionality in OVS, so that we can have the full data path be in OVS. Yeah.
So yeah, so just what I want to say is currently the only thing that we actually can offload will be able to offload is the pod-to-pod traffic until all these queue proxy pieces will go away, and then we can start also see if we can also offload the services, okay? Because it depends on what will be the data path pipeline and everything.
Yeah, that's a good point, but I think we can start testing your proposal for pod-to-pod traffic and see if we can still have the full offload after we support services.
Okay.
So I have a basic question. So do you think your proposal can work on other hardware too, or since
yes.
I don't, yeah, go ahead.
Yes, because the concept of the concept is very generic. So if you have another vendor that supports the VAF representative concept, so basically the code is vendor agnostic. So I know there are libraries that's called SRLVNet, which is doing some of the magic of looking for the VAF representative pair of the PCI address and stuff, but it's not a Mellanox proprietary, although it's in Mellanox GitHub. It's just a helper function that we didn't have a place to put it. But the way that we look for the VAF representatives is a common standard in the Linux kernel. So everything is a standard. If there is another vendor that's using the same TC flower stuff and is according to the Linux standard, the Linux kernel inbox upstream should work.
Got it. So basically, you are saying SR VF is typical where people do OS offloading to hardware, right?
Sorry, I didn't understand the question.
I mean, is that SRV is a common way people enable OS offloading and NIC?
Yes.
I see. And in your knowledge, do you know any other NICs can also do this full offloading, including a connection tracker for open usage?
I know other vendors that can do full offload from the feature set that they have. I'm not sure if they have connection tracker.
Okay, got it.
Okay.
Thank you.
It's basically it's dependent on the vendor. So what happens in the OVS is currently we have all the, like you said, we have the framework that actually changes and move all the translate the data path flow to TC for the kernel API. And now it's up to the vendor. Either it's going from TC software if you don't have the implementation as a vendor, or it's going to TC by hardware, and then it means that actually the data path flows or the TCs are TC flower is actually right, it's doing it in the NIC itself. So I know what Mellanox supports. I don't know exactly what other vendors support. Anyone that accepts Mellanox connection track.
Got it.
Do you have any insight about how many flows a ConnectX card can support in hardware?
With connection tracking?
Yeah.
Um,
I mean, Antrea uses connection tracking for every flow, right? So basically, yeah,
so
can be offloaded. Yeah.
So connection tracking is fairly new, and they are really working on improving, flow insertion rate and supporting many connections. I need to speak with the driver team. There are goals that they want to achieve. I can say that we are still not there, but there are goals that they want to achieve, and they are still working on it. If you want the numbers, I can provide, but I need to check it well internally on exactly what are the goals and the improvements they want to do. Okay,
yeah, I think I was looking for like an order of magnitude. Like is it 1,000 or is it like 100,000?
From the flows, if I remember correctly, they're talking about millions, but
Okay.
I need to check it. Okay, but this is what the numbers are talking about.
Okay, sounds
if
good.
I remember correctly. The goal is to go to 1 million.
So for this feature to work, do you still need to upstream any TC flower change to the kernel or to the OVS so that we can have something working?
So regarding the OVS, all the pieces from the OVS are upstreaming to the 13. So all the TC flower connection there, all the bits are there. I think now basically it's more of a driver improvement and stability of the connection tracking feature in the Mellanox driver. So basically all the pieces that are part of the framework like OPS and the TC Flower, all the bits are already in the Linux kernel.
Okay, thank you.
Moshe, I have two possibly stupid questions. The first is I was looking at the changes that you are proposing for Antrea, and I was wondering if there is any way with some sort of, I don't know, mocks simulation or anything that we could use to run this run this in the internal CI, sorry, in the upstream CI, or whether there is the need of having Mellanox hardware to test this code. I mean, I don't know if there is any way to simulate it so that we can, we can functionally test it without actually having the hardware.
So I can say what we are doing.
Mosh, we can't hear you anymore.
Sorry. So I can say what we are doing with CI. So currently we run it on bare metal nodes with Mellanox. We have a way to do some kind of a simulation, but it's all Mellanox proprietary, and I don't think we can share. But what I can suggest is maybe we can, I come from OpenStack and the familiar, there is the third-party CI and stuff like that. Maybe with Mellanox we can do, run a job on a Mellanox server internally in hardware and just do a comment in GitHub. So this is what basically we are doing with the SRIV device plugin at the moment to see that we are not break perspective the Intel GitHub.
Yep. I mean that was my follow-up question. Can you do the CI for us as a third-party CI?
Yeah.
Okay, and that would be great. And I don't think
that
we're
probably going to take you up on this offer, though, and the meeting is recorded. So
yeah, exactly, exactly. We got him on record, so now he has to make the CI available. That would be great because you're making changes in. You are adding your changes, let's say, in line with the traditional interface processing. So it's very likely that some contributor will break your code. Not, because, and therefore it will be good to have it checked by a CI. The other question that I have is more about interface attachment. So it's not clear to me if at the moment we only support traditional Ethernet interfaces or we also end up supporting DPDK interfaces.
You mean obviously DPDK? What do you mean DPDK interfaces? Just to, do you want to run DPDK in the container itself, in the pod, or DPDK? Obviously.
You're breaking up again, I'm afraid.
I'm asking regarding DPDK, you are talking about running DPDK in the pod, or you're talking about OVS?
No, I'm talking about supporting containers that have DPDK interfaces, that require DPDK interfaces.
But so the DPDK will run in the container itself, right?
Yeah.
So from Mellanox perspective, and this is a little bit different from the other folks. So Mellanox DPDK driver is defaulted. It means that it's half lives in the kernel and half user space, something like that. From the Mellanox perspective, what you need to do is just to when you create the network, the resource, there is a flag in the SRV device plugin to allow it to work with RDMA. Okay, once you enable RDMA, from the Mellanox perspective, it means that you can run a DPDK application in the container. That's the only difference.
I
For
see.
other vendors which are not bifurcated, like Intel, which using everything is user space. I don't know how it can work or if it can. Because the DPDK, their DPDK is totally different from architecturally.
I see. Okay.
Okay. But for Mellanox, it's just to enable a flag on the in the device plugin for the resource to enable RDMA, and then you can do RDMA and you can do PDK application.
Okay. Thanks for your answer. That's clear now. Thanks.
Another point I wanted to say in the non-goal, just that it will be clear. So of course, SRAOV, you need something to reconfigure the machine before you deploy Kubernetes, or at least the device plugin. So basically, you need to enable SRAOV, right? It's not enough. You also need to put we call it the switch mode. In SRAOV, there is legacy mode, which was the old SRAOV, and switch mode, which is new, which actually creates the buff representer. So it's some kind of configuration that needs to be done. The document currently doesn't address it. And from the framework perspective, there are, not sure if you're familiar, but for OpenShift, for example, they're doing the configuration using operators, and I know probably each distribution Kubernetes has its own way of doing this configuration or additional configuration. So I just wanted to let you know that currently it doesn't address this one, and maybe like it's specific to Antrea, but the full solution, so it will be fully automated and easy. We need to think about how to do that.
And before everything is fully automated, do you think that you can provide some documentation as part of your PR to explain?
Yeah, of course. Yeah, I can. Of course, I will add the documentation section on OVSR, the offload with what are the requirements from the OVS, from the kernel perspective, okay, and how to do the configuration of the SRAOV, okay, and basically how to orchestrate the pod, because as you can see, we are still dependent on the SRAOV device plugin and Multus, and the pod spec is also different because we need to request the resource. The SRAOV resource. Yeah, so of course I will document all of those bits, but we have ready to push it something that more than POC code that can be put to apps. And another point, just to be clear, when using SRAOV compared to VTH pair, so the solution here works also nicely that you can only pods that request an SRAOV resource will get accelerated. If you don't request the resource in the pod spec, it means that you don't want it to be accelerated, and we fall back to the VTH, network interface. Okay, so basically you can have a mix of accelerated pods and non-accelerated pods. Everything should talk to everything.
That's very cool. Any more questions, guys?
So talking about the PR, when you think you're ready to open a PR for review, I know you have the POC code already saw the commit. Do you think something we can assume can be ready for review in short term, like this month? Or?
Sorry, what was the question?
I mean, for the PR, for pull request, when you feel ready to create a pull request for review.
So there are two things. First of all, the point of the proposal was to see that you are okay with the design, because you know there are different pieces that we need to orchestrate this stuff, like dependency in SRV device plugin and Multus. And I wanted, first of all, to make sure that we don't have any gaps or here from that perspective. The next thing that we need to do on the Mellanox side is to do the upstream code, and also I need to take the bits from the Mellanox driver, meaning take the latest kernel OVS 2.13 and see if we have gaps here in the upload capabilities. I still haven't done that, and I think once I will do that, and in parallel we will work on the upstream code. Only once I know that we can offload the traffic, then I will push it. Although they are not that dependent in each other, but
Okay, got it.
but I think it will take us like a few months to, because I want to see that the port-to-port traffic is actually working. I didn't have it. We didn't get to that point that we are taking all the latest bits from the kernel and really try to see that point.
Got it.
Once we will do that, I will feel more comfortable to push this code upstream. Then we
I see. I think from our side, we are very eager to get this OS offloading done with Antrea. So if you need any help from us, I think we'll be very glad to help you and work together on this.
And I
sure.
think we're fine with the approach that you describe in the document, with the dependency on Multus and everything, because it's still software that you have to install separately. So it's all fine by me.
Yeah, so the reason I would choose all the Multus pass, because just to pass the device ID. The other, I didn't write it as an alternative, but the other way is to put so much logic in Antrea just to talk to Kubernetes and get the resources and basically clone what Multus is already doing, just to find a match from the resource and the PI address. So from the Mellanox side, feel this way, it's more isolated, although we add an extra component, but we don't want to put unnecessary logic to the Antrea CNI that we can avoid. So that's why we did it. And so from the orchestration, it's a bit more complex, but I think from code perspective, it's much linear, and then the Antrea changes are I think mostly isolated from the other stuff. So the point was just that we have an agreement on the way that we want to do it. And I think once you give us from your perspective, that design is okay and everything, then I will take it internally in Mellanox and we can progress this work and feature and everything. So.
Yeah, makes sense to me.
Sorry, I joined a bit late. If you've already answered this question, I can go back to the recording. But I saw you mention the topology manager feature that you're going to use. Can you shed some light on that? I mean, what kind of changes that you need to make with that feature, or is it something that you're just documenting that you'll be using that?
Oh, basically, there's no change. We're just going to use it. So it means that you need at least Kubernetes 1.16. This is the first time that this feature was introduced. From the configuration perspective, it's just we're using the policy for the single unit, just to make sure that the CPUs and the NIC PCI is aligned on the same NUMA for better performance. This can still work without topology manager, but maybe there will be a performance degradation. So that's the only thing. There's no changes in topology manager. We're not planning to do anything standard or something like that. Just that, and if you don't have it because you have an older Kubernetes version or something like that, it will work. Everything will work. Maybe you will have a performance degradation.
Good.
Okay, thanks a lot, Moshe. We appreciate you coming. I know it's early for you and presenting this to the group.
Thank you.
Okay.
And I believe that we can move to the next topic, as Cody mentioned that there was some feedback on cluster network policy. Therefore, Cody.
But before we do that, I saw that Antrea was on the call. I just want to make sure that the CLA was received and you guys are working on that as well. Maybe you didn't hear. I'll follow up afterwards. All right, so on the network policy, I had a couple of...
Sorry, can you hear me now?
I can hear you now.
Okay, sorry for that. I was on mute. Yeah, we received your CLA agreement. Thank you for providing that. We'll work on that. It might take more time with the Mellanox being acquired by NVIDIA, but I will make sure to process it.
Sure, perfect.
Thank you.
Thank you. Okay, so back to cluster network policy. I apologize, I was unable to attend last meeting, but I know that Abhishek, you presented on network policy. I had a couple of questions and some feedback on that. I wanted to run past the group. Let me share my screen. Can you see my screen?
Yes.
Yep.
Great. So one of the questions I had was in thinking about cluster level policy, and actually let me show a diagram before we go there. So in thinking about cluster level policy, I was going to talk a little bit about the way that Calico handles this. And I know I've got tiering or categories put in here and we're not quite there yet, but I think it's important to talk about ordering of policies and how we want to treat things. In the document, we were talking about treating Kubernetes network policies and cluster level network policies as different orderings, where the way that Calico does it, it basically treats the entire block of Kubernetes network policies as an equal entity to other cluster level network or native policies, I would say, not just cluster level, but native policies. So really the difference is Kubernetes network policies versus an Antrea native policy in this case. And then the order of this block here is a globally defined value that can be changed. And then you can basically structure policies in that bottom tier category around that block. I just wanted to get some feedback about that question first and understand some of the reasoning, because I know that we were also dedicating specific OVS tables to the ordering of those policies and how that might impact the design.
So is your question that are we going to treat the Kubernetes network policies as one block at the bottom of the tier?
Right. So the question was, yeah. So basically, if you treated the Kubernetes network policies as a single block, then basically policy ordering works the same way across this block or any other native policy, whether it be namespaced or cluster policy.
I see. So, so what is the? I mean, maybe I can get a. If you can give me a user story, as in what
Sure.
is the story here, so maybe we can then use that and define?
Sure. So the story might be is you may want to sandwich. So for one user story maybe is you may want to limit certain users, application developers, for example, to only be able to create Kubernetes network policies. A lot of enterprises do that. But you may want to sandwich their Kubernetes network policies, between native Kubernetes network policies and actually evaluate them in an ordered fashion, as an example.
I see. Okay. And got it. So I think that's
and this might be like if you don't want your default rule to be deny all, but you want your default rule to basically to be deny all except 443 or something like that, right? So if they don't explicitly allow 443 or 80, you might be able to set a default rule to allow that. So you would have to have, in this case, a rule, somewhere down here would be, a global or a namespace rule that would enable that communication if you didn't do an explicit deny all.
And in this case, would you also require that the upstream Kubernetes network policies can also be defined in a different tier, like in your case, app operator tier, or it's just
no, this entire block would have to be relegated to a single tier. The way that Calico handles it, it's called a default tier. It could be a, it needs to be basically the tier, because Kubernetes network policies do not have a tier specification, right? So they have to land in a quote unquote default tier for that to work. And then you could specify what you wanted that order of that default tier to be. Typically it's the last tier, evaluated. But I just wanted to, see if that made sense, or if that was, going to really bend the implementation plan.
Not really. I mean, so you mentioned that, I think Calico does not do or allow you to create policies in the default tier, right? Because I think they have, the default tier is represented by like a nil order. So I don't know if they accept that in their native policies. Perhaps
you can create native policies in the default tier.
You can? Okay.
Yes.
All right. And so what about the ordering between the policies? Like, so in your case, I see there is a green box below the Kubernetes network policy block, right? How do you define
Correct.
that? How do you define that relative ordering between the two policies?
So we would have, great question. So we would have to have a part of the configuration CRD or a state, a static state would have to store what the order number is for the Kubernetes network policy block, right? Because that's a synthetic value, right? You can't store that on a Kubernetes network policy. There would have to be a synthetic value representing that, and so we could either do that with, a separate CRD or a configuration option in a global, configuration CRD.
Yeah, because essentially then that would mean that the users would need to know what should be set in their order in their policy so that it goes below the Kubernetes network policy block.
That's right. They would have to know that. Typically the way that's handled in Calico is that block falls below, that block is set to like an arbitrarily high number, right? And so all the policies that are created get evaluated before that, unless they change that.
Okay, because there's also the other option that if you want to have like something which goes at the bottom, maybe use some CNI config option for the entire cluster.
Right. And that was the other thing with this, what this defaults here represented was, imagine a lot of people want to put a global default deny in place. Typically the way Kubernetes network policies work within namespaces, if no policies are defined at all, then there is no default deny, right? You have to define at least one policy to get the default deny. And the way that some had approached that was they would always ensure that they had a rule at the very end of this default tier that would be a default deny all if none of the other policies matched. However, when you get into how do you control access to that tier, and which types of policies that if you want others to have access to a certain set of policies within that tier, what some enterprises found was that it was difficult to ensure that there was always that policy at the very end of the tier, and so they asked for a configuration option instead that basically allows you to either define all namespaces or a single or a set of namespaces to have a behavior of default denial for their namespace, and that's a configuration option rather than a policy that could be controlled by a separate RBAC value.
I have a question. If you have a policy below Kubernetes network policy block, then what will be the default behavior of the Kubernetes network policy? For example, in Kubernetes by default you allow all, right? But once you create an ingress policy, for example, then you allow only traffic defined in the policy. But you drop other traffic for the ports selected by the ingress policy. But if you have a policy below Kubernetes network policy, do you want to keep the same behavior, or you think we don't need to by default also deny the traffic not specified by the ingress policy?
So you could treat that one of two ways. You could treat it with if a configuration wasn't set for this default behavior, right? Mm-hmm. Or it didn't apply to a namespace, we would fall back to the standard Kubernetes behavior of allow all traffic unless any policy matches a workload or a pod, right? If for example you were to use a policy to represent that default behavior, what that would mean is if you didn't have in a particular namespace, say namespace C didn't have any policies applied mm-hmm. to it, then the default behavior in Kubernetes, given that there's no other policies up here, right, matching namespace C would be to just allow any traffic through, but you could have a global policy that matches all namespaces down here that would basically be your default deny all. Yeah. In that case. And really this is more about once you start getting into RBAC and deciding which users have access to apply policies into which namespaces and to which tiers, that's where it starts getting tricky.
Sure. Actually, I got that one. But my question is more like once you have the policy, Kubernetes network policy. Kubernetes network policy basically allow only the traffic defined by the policy rule for the drop other traffic, right? In your case, if you have a policy below Kubernetes network policy, do you want to keep the behavior?
Well, this policy below could or could not match multiple namespaces. So it may not match one of the namespaces listed in this block. Mm-hmm. Is that what you're, so it would depend on.
Let's talk about a specific example. Let's assume you have a Kubernetes network policy that allow all the traffic, ingress traffic to TCP port 80.
Okay.
Then if you don't have any policy below, the standard behavior that you allow only TCP port 80, but you will add a rule to delay any other traffic.
Well, the first policy that matches, so this entire block would have a policy that matched first, and so there would be a terminal action. So this wouldn't even, if it was ingress traffic on port 80, you would never actually see this evaluation down here for that particular traffic.
My question more like what will happen that if you don't have any policy below, you will, for example, when we implement policy with open switch, you add a flow to allow port 80.
Right.
But you will also add another flow to drop all other traffic that is not to port 80.
Okay.
my question for you that if you assume there can be policy below Kubernetes policy, do you want to add a second rule to drop other traffic or other traffic to not to port 80?
Yeah, because it would be taking on the standard. Yes, you would have to have the rule to drop all other traffic, because even if one of these here matched for that namespace, then it's the standard Kubernetes behavior of you assigned at least one policy. That means that it's deny all for anything that wasn't explicitly declared.
Okay.
So yes, that would be the same. I mean, it's the same behavior.
Okay, so basically you're saying the policy below Kubernetes policy can only use to delay traffic, but you cannot have you cannot really control the Kubernetes policy.
That's right. That's right. It could only be used to deny certain types of traffic.
I see.
In a global way. That's right.
Okay, got it. Okay,
So
maybe that also works.
Okay. So the other question I had was there a reason that we need to explicitly declare external entities selectors, or can we do all selection of endpoints or workloads based on metadata? Is there a reason for separating that out?
What do you mean by metadata? Whose metadata?
Cody, maybe we should talk more about this. I mean, it's the total entity selector. I'm not sure you know the context. It's
Okay,
more
sure.
for entities not managed by Kubernetes. For example, it can be standalone VMs.
Right. The question I was asking is if we are exchanging inventory with another control plane that we want to either receive policies from. The question I have here is, can any specific attributes that are needed to identify an endpoint be elevated during that inventory exchange to, can those attributes be elevated to just a standard label, key, and value by some pattern, and we select only on those patterns? Or because it seems to me that having this would be almost very specific to the type of integration you would want to do with another control plane to receive policy. I'm just trying to make it more generic.
But you need some resource in Kubernetes API for your external entity, right? It's not a pod or it's not a node, it's something else, right? You need a CRD, whatever. You
basically need an IP address, right? That you're going to have your.
We want to do dynamic grouping for external entity too, right? For example, it can be a public cloud VM. It can have some tags on the VM.
Right. What I'm saying is, when you actually render the OVS table, at the end of the day, you need an IP address, right?
Right.
My question is, so you're going to have some type of adapter that brings in inventory, right?
Yes.
From another entity. That inventory could be a mapping of metadata to IP address, right? Based on that inventory. When we bring in inventory, if we need something specific, a specific label like this, for example, can that just be elevated to a standard key value mapping, and then that way it's generic across any type of connector that we put in place?
I'm not sure I got what I mean, but when you say inventory, you mean you want to support some inventory CRD in Kubernetes?
Not an inventory. This is. Go ahead.
Don't you think we would have to write a controller for each class, for each cloud, for example, and then that controller would automatically take the metadata of your AWS VM, for example, and translate it into labels? So that would be automatic. We would need to write a controller, but that translation would be automatic. Do you mean something else?
Yeah, you're already writing an adapter, right, to pull the inventory in.
That would be the idea, yeah. And
so since you're already writing the adapter, just elevate any specific attributes to be a standard key value pair, even if you need to namespace them, right, to make them more unique or something like that. You could still namespace the keys of the metadata with their values, and I just think it would make the
I
the
agree, but
workload selector.
It's
more
talking
generic.
also this proposal, right? It's completely compatible with this proposal because those external entity objects are going to be initialized by the code that you have that's bringing in the inventory. And as part of creating those objects in the Kubernetes API server, we can do translation of cloud native metadata to Kubernetes labels.
I think where I was going with this is if you used a similar metadata tag for both external entities and internal entities, I now have to specify that tag twice in my policy, right? Instead of being able to write a generic policy that says I want to, accept all ingress from pods of this type, I could have, workloads of this type. I could have workloads both as pods and as external entities that match that metadata.
So,
It would function using this. It's just you're duplicating yourself, right?
so I'm trying to understand, are you suggesting to replace the external entity selector, namespace selector, pod selector by a generic selector which would just match on these labels? Is that what you're trying to do?
Yeah, basically I'm calling it more of an endpoint selector than a pod selector, right? You really, at the end of the day, when you're building your filtering rules, what you're filtering on are endpoints that have some type of metadata attached, whether it be a pod or an external entity, which could be like a VM.
We discussed that, right, Abhishek? And I think we said that if someone is using those policies just in the context of Kubernetes, it's nice to be able to use like pod selector, like in the actual Kubernetes network.
That's where I was going. That I think the selectors that we are trying to introduce are more Kubernetes style, wherein you otherwise you will, if you want to specifically only target pods and not other endpoints which you may have in your system, then it's a little bit tricky to get that into the system. Like if you just have a generic selector, then it would select all kinds of endpoints. But if you want to filter them on pods, let's say, then you might have to do some more layers of filtering on top of it.
I think
So,
based on that, we at least have pod selector, but maybe we can argue if we want to have a generic selector can select everything, or we want to have an external entity select only to select the external entity.
I mean, we can have pod selector, external entity selector, and endpoint selector, right? But the question is this a good idea?
Yeah. By the way, actually my idea, finally, I think better to support some grouping concept, just to define a group, and the multiple policy can reference the same group. And then maybe in that group concept, we can make it generic. I mean, you can select any endpoints.
Yeah.
For sure, we can decide more. I guess
let's take this off. Yeah, let's take this offline and discuss this more. Really, at the end of the day, I get the idea of wanting to use pod selector because when you're writing policies in Kubernetes, you're seeing everything as a pod. What I'm trying to do is decouple and see that any type of endpoint selection for a policy any of these can be converted into basically a key value pair and just make it more flexible from that perspective, so that I don't have to worry about where that entity is, because quite frankly you could have migrations occurring where one day those entities are VMs, the next day those entities end up getting containerized and be put into your cluster, right? And it would be nice if your policies just continued to work as you had intended them.
Yep. I can agree, but I just mean at least we should support some Kubernetes native semantic first. So for people, since most of our consumers are still Kubernetes only workload. Right?
Sure, makes sense. The only other question I had was conveying cluster network policy rule metrics as the status field in CRDs. My question is that in terms of the status fields of CRDs, those are typically, reflecting current state and not necessarily time series values or metrics. And so I know there was a question already asked about scale. If we intend for those to typically be just time series observables, Do we actually need them in a CRD? Is anybody that's going to be observing them just going to hit the Prometheus scrape point or other mechanism we use to expose those instead of hitting the CRD? Wanted to get some understanding of the justification on that.
I think for the metrics part, I think Chan had a proposal for it. And I think he wanted to spend more time on it and come back in a later meeting.
Okay.
So I don't know
Great.
if he's online, but if he's not, then maybe we can take it up in the next meeting.
Sounds good. That's the only feedback I had on that.
And do you think that we can stay on the current meeting schedule, or do you believe that we need an extra meeting to discuss this feedback in a more timely fashion?
I think that I'd like to at least get some of these answered before next week. So if we could, discuss this again in a week's time, that would be great. Especially considering this is the last, or we want to get this into the next release, right? So.
Well, yeah, okay. So yeah, we probably, I don't know, maybe even discussing it again next week could be too late if you want to have it in the next release.
Right.
Yeah, maybe
actually,
we can. Yeah, go ahead. So go ahead, John.
Sorry, actually, I would say for last release, if something is feasible, let's just do something minimal. Probably don't have external entity, and probably don't have fancy metric stuff, and probably you don't have many priority choice.
I agree with the phased approach. I think we could take a phased approach here and implement, the first steps of this, and then extend the definition in the next release if we wanted to do that approach as well.
Okay, so I mean, it might
That's
make
reasonable.
sense to me. It might make sense to me to discuss this further and close down, perhaps, and close down on this topic perhaps during this week without having to wait the next Monday or Tuesday. And
that'd be great.
Yeah, so maybe we can, Abhishek, perhaps if that works for you, you can try and propose a meeting and share it on the Slack channel so that we can have another topic. We can have another call on the topic during this week. And said that, I think we are already 4 minutes over time, and I know that for some people, Cody, it's extremely late already. So maybe the people in Palo Alto and Cody want to get some rest now. Is there anything else that you would like to bring up for today? Otherwise, I will stop the recording. Going 5.
That's all I had.
4, 3, 2, 1, 0. So that's all for today. I'm going to stop the recording now.